Welcome everyone, this is the second lesson about modules. We made one last week, and today we'll go more into the details on how we can define modules in Rust and also submodules and a couple of more features. This will be a theoretical but also exercise. We'll also make some example. We'll see some examples. I prepared some small projects, and this is a problem that we usually have when we have a programming language, understanding how can we structure the code in multiple files. So far we used a single main.rs file. This is not sustainable for big projects. I already said that for bigger projects, like huge projects, there is something called workspaces in Rust. Today we're just focusing on, a little bigger projects that when one file is no more enough. It's not enough anymore. How can we define modules? What's the keyword in Rust? Modules are defined using the mod keyword. You can see it here. We'll also see this in the code soon. You can also see here many different new keywords. We see a pub, which stands for public. We have also this one, which is use. We'll see also what use is. Spoiler, is very similar to what we have in JavaScript. So again, modules are used to define and control the scope, so the visibility and the privacy. This part is very important. We'll have a slide later about also the privacy of the items, the functions, and the struct defined inside a module. So let's check the example. I have 3 examples, and one of them is this one, the garden one. So let's see the structure. Now, this file should be familiar, this main.rs. Let's see the structure. We can see some familiar files. We have a cargo.toml file. It's very similar to a package.json or requirements.txt for Python. We have a .gitignore. We have a main.rs file inside this src folder, and this is what we had so far. But there is something different here. First of all, in this main file, we see, as I said before, different and new keywords. We have this use create with also this double colon structure, and then we have this pub mod garden. So we'll go into the details of each of these lines, but for now let's just have a look. We have this main file, a garden.rs file. Inside this garden.rs file, I was expecting more here, but instead we have only this single line, pub mod vegetables. Where is this vegetables? If you open this folder here, the code will be available, no worries. We have this folder called garden. Inside this, we have what is called a submodule. So in this project, we basically have create root, which is the main.rs file. It's basically the first file that is that the compiler looks into. And then we have the garden module, and then the vegetables.rs submodule that has something. It has a struct, which is public, so it's publicly available on the module and also in the create root. So this is just to have an idea. Let's go back here, and now let's see 7 rules for models. And now let's see 7 rules for modules, rules or concepts, I would say. Number 1, the compiler always first looks in the create root file. This can be a main.rs file, or in case we create a create library, which is this is not an executable, but it's a binary. When we create the project, we can create this using a -- lib option. We will do this when it's necessary. And so this is why when we create a project, we start from here. So the compiler starts from here, and then it reads any other submodule that we can use. How can we declare a module in Rust? For example, we can do something like this. We can declare a garden module inside this main.rs. So main.rs, and then we define a module. Now, defining a module is not the same as writing a module. So this is how to this is just to explain how this module can be read by the main.rs file. And there are different ways that the compiler can have to look into the actual code of the module. We have the inline, we'll see this, in a file, garden.rs, this is our case, or we can also have inside a folder a special file called mod.rs. In our case, this one, we have the second option. So we have a main.rs file, and then we have a garden.rs file. So this pub mod garden online 3 reads this garden.rs file that has another submodule. We will see this soon. As I said, number 3, declaring submodules. Submodules can be declared in other files that is not the create root. So in a file which is not the create root, so not the main.rs file, we can define a submodule. And the structure is very similar to a module. For example, in this case, we have this vegetables submodule, and it's a similar structure. We can have an inline one, we can have this submodule inside the folder of the module, or inside a subfolder of this folder. Let's see in our case what we are using. You can see here we have this garden.rs, it's the number 2, so we have this one, and then it reads this file called rs inside the garden module folder. I hope this is clear, this structure. So if this structure is clear, we can keep going. For someone, it could be easier to have a mod.rs file inside a specific folder, but in this case I will have different files called mod.rs file. Usually I try to avoid this. For example, even when I create Docker files, I try to avoid having different files with the same name in the same project and having just the structure of the folder to define the logic. This is something that I try to avoid. So usually in a project that has multiple Docker files, I don't have multiple files called Docker file in different folders. I don't know what's your style. I try to avoid this because I'm already sure that I will modify a different file just because I read the file name here. So I think this is a bit it's clear. Let's say that we are in this submodule. Okay, 1 second. Okay. Rule number 4, paths to code in modules. So when we create a module, so when we define a module in a crate, we can refer to some code that is inside this module, and we'll use something called the paths. Okay, and it's interesting that once we define this crate somewhere, we can use the same crate in other places because they've been added inside this crate. For example, here, when we can see here on line 3, you can see here on line 3, pubmod garden, the garden crate will be available in the whole crate, in the whole big crate. And now something that should sound familiar, the use keyword. What's the use keyword? It's very simple. The use keyword creates a shortcut. It's a shortcut to avoid typing. The use keyword creates a shortcut to items. Items can be structs, functions, enums, and so on. because we want to reduce the repetition, especially of long path. Check here on line 1, we type use create double colon garden double colon vegetables double colon asparagus. Instead of typing every time create garden vegetables asparagus, once we type use, you can create a shortcut and then we can just use, for example, here asparagus. I think we can also add an S here, for example, SX, and then we can even change the name. In this case, I just want to use something simple. I want to also show in the code how this was done. Here in the main RS file, we will try to run this code soon, but just wanted to show you this also on VS Code. So you can see here number 1 use, and then we can just have this of the type asparagus. It's interesting because I can also control click and it also goes directly here in the definition. Very cool. I think that this is an extension, but it's cool. I think this concept should be clear, right? This concept of use is basically just to so we don't have to type this over and over again. Oh, let's see. Okay, let's see just 2 more concepts. The first one is private versus public. So by default, and this is very important, the code within a module is private from its parent modules. So the fact that a module is public doesn't make the functions inside that module all public by default. It's the opposite. They are all private by default. And this might sound strange, but let's see an example here. To make items in a public module to be available public, you also need to add pub before their declaration. Let's see this example. We can see this in the code directly. I think it's easier. No. Let me find the right project. Okay, this is the right project. You see here, first of all, I defined a module here directly in the same file. This was just an example to simplify and also to showcase that you can also create a module in the same file. It was the option number 1. So here we can see we have a public module called network for networking, and then we can see we have on line 4 a function connect without pub here at the beginning, which does the connection. And then below on line 9 we have a public function pub fn initiate connection. Why? This is of course a simulation, it's a demo, but just to let you know that when in the main function I want to initialize a connection, I'm not using the private function to establish a connection, but I'm calling the public function inside the module, and then the module might have something that is used inside the module. You can see here on line 10, we call the function connect. So the module network, of course, has the visibility of the function connect, but the external module, the main module, can't call directly this connect. It has to use this basically public interface. Okay, so I hope this is it's clear, because this is very important if I want to structure the code. So by default, the functions and items that are inside a public module, they're not exposed to the parent module, but they need to be explicitly public. So this does mean that then the parent module can use them. Is it clear? I hope so. You're welcome, Tifus. I don't know if it was me or Atarva or Shub. It was me. It was me. but I also made the membership because of Atar Venshub, so it's still the credit to them. Okay, let's try to type this cargo run -q, and we can see here connection established, initiating connection. If I try, for example, here to call directly this network connect, you see Rust Analyzer, it's already complaining. Here, I should get an error. Let's read it here. Private function. So I can't call the private function connect in the module network. I hope this is clear. Okay. Let's go back here and let's go in this one. This is the rule number 7, and this is the last rule of today, rule concept. What about grouping in modules? Can we group code and functionalities for different modules, and why should we do that? We will see an example soon. For now, let's just focus on the fact that you can use modules to organize your code for not just better readability, it's not just about readability, but also because maybe I want to separate responsibilities, and maybe I want to provide both modules on the crate, but I don't want, for example, a module to call other functions that are on similar modules at the same level. It's easier to see this directly with this project. So we have this module called restaurant, which is a nice example. So let's say that we want to have two different sub-modules inside this restaurant module. We want, because they are all connected to the restaurant concept and to the restaurant module, but we want some functionalities that we can group in a sub-module for the front of the house. It means that like all of the serving parts, it's exposed to the public. And then we want something private, like back of the house, so prepare food, wash dishes, and so on, order some food, and so on. So, and I think this is clear. I hope that this is clear. And this does mean that when I use some of the functionalities here, for example, I can't have the back of house calling some functionalities that are they are of another module. Okay, so again, this is just to structure our code better. And you can see we have a module inside a module inside a module here. We have, for example, we have this module restaurant. Inside of this, we have two modules at the same level, front of house and back of house. Inside the front of house, we have different modules, so hosting and serving. And for the back of house, we have just at the same level, prepare food and wash dishes. So this is just to say, let me do this. Terminal position right. And then we can do cargo run -q, and we can see that we are calling all the functionalities based on the front of house. I can't, for example, do this because in this case, for example, these functionalities, they are inside this module, but they're not available and they are not public. You see also the visibility here. So something can still be done inside the module restaurant, but from the outside, like from the app, you can't choose what will happen in the kitchen, for example, or in the back of the restaurant. So this is not available, for example, to the public. Okay, and this is the end of this lesson. I don't know if there is something else that I wanted to show. Let's see if I'm done. No, we are done here. Maybe I want to show here. I wanted to show. I promised that I would have done something here. Okay. The last example that I promised that I would have tried is this one. Let's say is the main one. So we have this main file here. We are using a submodule of garden. So we are using main, the module garden, the sub-module vegetables. Inside this one we have a struct. You can see the video about struct, and then we can try to print this plant asparagus that we define here in the main function. So let's try here like this. We can type cargo run -q, and we can see we have here the output. It's very important to understand everything that happened behind the scenes. So here we have defined this plant of type asparagus that it's not defined directly in here. We don't have a struct here in the main function as we did, for example, in the lesson about structs, but it's inside a sub-module of the garden. For example, here I could have, I don't know, all the vegetables, and for example, I can organize here all the struct, but like think about having like 10, 20, 30 types of different plants for a garden. It would make sense to have a place where I put all the types of the plants, and then I do something else here on the main function. Okay, this is the end of the lesson. I hope you enjoyed it, and it's very important to understand how to structure. It's very important to understand how to structure our code in different files, different libraries, different modules. Okay, we are done. Let me stop recording.